Okay. Okay, so for the Pythagorean theorem, the way the Pythagorean theorem works is it says that if you have a right triangle, so you have a guy here and he's got a right angle, then you name the longest one across from the right angle the hypotenuse, and the other two are going to be called the legs. The hypotenuse is always given the letter C, and the legs can be given A and B, and it doesn't matter which one is which. And if you have all of this stuff, you have a right triangle, and you've named everything A, B, and C, then we know that A squared plus B squared will always equal C squared. So an example of that down here is if you have a 6, 8, and X triangle, it's got a right angle in it, and so you go, okay, if it's got a right angle, it's a right triangle. So this formula must work. And so I can do this guy be A, this guy be B, and the hypotenuse across from the right angle is C. So I can do 6 squared plus 8 squared equals C squared. And so 6 squared is 36, 8 squared is 64, and C squared is just C squared. We don't know how big it is yet. But of course you know how to add, and 36 plus 64 is conveniently 100, equaling C squared. And notice how I'm writing out the steps every time, because a lot of people try and just do this in their head and then they get confused. Write it out. And then to get rid of the squared, you're going to do square root on both sides, which is why we have been learning all our radical rules. And the squared and the root will cancel out, and C will equal 100. Now, there is a negative square root of 100, isn't it? 10. Yeah, sorry, that should have been a 10. Get candy. Now, there is a negative square root of 100, a negative 10, but we're not going to use that here, because can you have a negative 10 as the side of a triangle? Not in this universe. So, in this case, we're just going to stick with the positive square roots, because we're doing stuff that's real. Now, you'll notice that the A and the B and the C all ended up being whole numbers. And when that happens, it's called a Pythagorean triple. A set of whole numbers, and we always write them in parentheses in order the smallest to the biggest. So that the biggest one, C, which is always your hypotenuse, will be the one at the end. And they're in alphabetical order, because what are we, animals? They've got to be in proper order. And so they're whole numbers, and they satisfy the Pythagorean theorem. And I get lazy, and I write it just as pith, and then because I don't want to write the whole thing. Okay? And there's a whole world full of these triples. You've got 3, 4, and 5 is a Pythagorean triple that works in this formula. If you double it, you get 6, 8, 10, which is conveniently the one that ended up in here. So if you had this memorized, you could avoid all this work and just see that I've got 6 and 8, and you could just know that 10 was the hypotenuse here. And that keeps going on. You can triple it and quadruple it and get more and more Pythagorean triples. Other sets are 5, 12, and 13, and then all the multiples there, like 10, 24, and 26, and it keeps going. You can also have 7, 24, and 25, and all of its multiples. And then you can have 8, and 15, and 17, and all of its multiples, and all of these work in the Pythagorean theorem, give you nice pretty whole numbers, and you don't have to get your calculator out because you got them memorized, and that lets you cut a corner. So you look down here at this one, and you're having to find x. Now, is x going to be A or B or C?
A or B.
A or B. Well, which is it?
B.
Whichever one you want. You can decide if you want this to be A or this to be B, and we don't care. But which one has to be a certain letter?
13.
The one opposite the right angle, 13, has to be C. And so you start looking at this and you go, wait a minute. I've got a leg is 5, the hypotenuse is 13, and it's a right triangle. Is this one of my triples?
Yes.
You go, this is my 5, 12, 13. So you could just come in here and put x is 12 and be done. But if you didn't have it memorized, you would have to go through and go, okay, if I make this one a and this one b, I could go 5 squared plus b squared equals 13 squared and do it the long way. Let's just double check it to make sure it's not lying. So let's see, that's 25 plus b squared. What's 13 squared? You're supposed to have it memorized. 169. And so you subtract the 25 from both sides, and b squared is 144. And you square root both sides. And what is the square root of 144?
12.
It's 12, because of course you memorized your perfect squares like you were supposed to. And look, it does match our Pythagorean triple, so I was not lying to you this time. Okay? When do we use this? They've been using it since ancient Egypt. For you, you get to draw a pretty picture. So in your notes, I'm telling you that a 25-foot ladder rests against the side of the house, and the base of the ladder is 6 feet away from the house. Sketch what that looks like. And sketch it the way it would be in the real world, so houses do not lean. We're not in Italy. We're going to be straight up and down. So you got some ground there. Got yourself a nice house. You got a ladder leaning against it. And we can assume safely that the house is going to be vertical and the ground will be horizontal. That's usually what they do when they build. Okay. What number goes where? Yes, Trent? What?
25 is the ladder.
The ladder is 25, so it's over here. Okay, what else do we got? Yes?
6 is the distance from the house and the building.
Yeah, so here's the base of the ladder, and the distance from it to the house is 6. So I don't know how high off the ground is the top of the ladder, but it's up there somewheres. And you look at this and, eureka, it's a right triangle. What formula are you allowed to use? Pythagorean theorem. Now which one gets to be C? The 25 gets to be C, so that's the one that's going to be by himself. So you're going to go, okay, x squared plus 6 squared equals 25 squared. Ooh, I have a triple with 25 being C, but does it have a 6 in it? No, so this is not going to be one of your whole number Pythagorean triples. You're going to actually have to do math here. So go ahead, math, math, math. Some people are not mathing. Don't make me throw an eraser at you. And so you're, okay, x squared plus 36 equals 625, which of course you didn't need a calculator for those because you memorized those ones, right?
Right.
Of course you did. And then you subtract the 36 from both sides, and x squared became how much? 589? And then you have to square root both sides. And, okay, when I give you something with a radical, listen, I will always want your answer in simplified radical form unless if I tell you a decimal to round to, you get to use a decimal. Otherwise, you have to leave it in the radical and simplify it. But I told you to make this one to the nearest tenth, so you get to plop that in your calculator and do root 589. The square root is above the squared button. So find x squared, and then you have to use the second button to get to it. And what is the square root of 589? It's 24.269 garbage, garbage, garbage. Because remember, it's going to be irrational. But lucky you, I told you you can round it to the nearest tenth. And so it'll be 24 point how much? I hear 27 and I hear 3. Which one is the tenths place? The first place here, so you're going to have to make it a 3. And then your answer is half wrong. Why is the answer halfway wrong?
You put equal.
Well, I mean, technically it is just approximately equal because we rounded, but that's actually not why it's half wrong. Yeah?
That's a good question.
Oh, well, how did I not answer the question? Yeah, it's naked. This is 24.3 what?
Feet.
Feet. If they give you units, you need to put the units in there. Just like on the last test, you had to put degrees on the measure of the angles or you lose points. If I give you units, you better use the units. Okay, turn it over.
Okay.
And now you have to think back to Unit 2, when we did logic.
I love that unit.
Cool, so you remember what a converse is.
Of course.
How do we get the converse of a statement?
We do QP.
Which tells me to do what?
Flip it.
Flip it around.
Like keep jumping over there.
Yeah, so like somebody was flipping around. See, we're always going to remember. So, the Pythagorean theorem has right triangle first, and then a squared, b squared, c squared second. What will the converse have? So if I have a squared plus b squared equals c squared, then what do you know?
It's a right.
That it better be a right triangle. That's the one that the Egyptians were using. They would check and see if they had 3, 4, 5, and if they had 3, 4, 5, then they knew they had a right angle, and all was well with the world. Okay? And so, for example, I give you this, and notice there is not a right angle in the corner. So I don't know which one of these is the right angle. Okay? And so I need to check to see if this is a right triangle. What should you do first? No, well, I mean, it doesn't simplify. That's 2 times 17. It doesn't simplify. No, what you need to do is figure out which of these sides gets to be C.
Oh.
You have to figure out which is the biggest number. Now, I know 9's not the biggest. But which is bigger, 3 or 34 or 15?
Can we do that in a calculator?
You could grab a calculator and just make sure which one of these is the bigger number. So you plug it in and hit equals, and what does 3 root 34 come out to be? 17.5 junk, junk, junk. So this one gets to be C. You always want to check that because you can't trust the picture. I'm warning you of that because on your homework I'm going to fool you with this. You will get bamboozled. And so you know this is the C. So now we're going to check. Does, let's make this A and B, 9 squared plus 15 squared really equal 3 root 34 squared? Okay? Now when you go to put this in your calculator, watch out. Because of course you know that 9 squared is 81. And you know that 15 squared is 225. But when you go to put 3 root 34 in, if you want to do it by hand, 3 root 34 times 3 root 34 is just 9 times 34. You could do that. But if you decide to put it in your calculator, you're going to put your parentheses. And you're going to put, 3 and then the square root of 34. If you try and just put your parentheses after that and then square it, notice that your exponent ends up underneath the radical. Is that where you want it to be?
No.
You do not want it to be there. So you're going to have to back up and delete all that stuff, okay? And before you go on, you need to arrow out from underneath your radical. Then put your parentheses outside of it and then square it. That way, when you get your answer, it's going to be correct. And it comes out to be 306. Okay? So now that you've got 306 here, now you need to check, what is 81 plus 225? Well, see, 5 and 1 is 6, 8 and 2 is 10, that's 306. Does 306 equal 306? Yes. Then this is a right triangle. Okay? Because if you don't test it, you don't know. If you had fallen for the bamboozle and, put the wrong thing in here, you might have gotten a different answer. So always make sure that you're using the biggest one. Now this begs the question, what if it doesn't equal C squared? Will you have a right triangle?
No, ma'am.
No. But guess what you do have then? You either have something bigger than right, which is obtuse, or you have something smaller than right, which is And did you know the Pythagorean theorem can tell you which one of those you have too? See, your teachers from elementary and junior high have been hiding all the good information from you. Okay? Because, look, check this out. I'm going to flip the Pythagorean theorem backwards. So if you have c squared equal to a squared plus b squared, what kind of triangle did you have? If c squared equaled a squared plus b squared, what did you have? You had a right triangle. Well, what if c squared is bigger than a squared plus b squared? Well, that would only happen if c was bigger than it should have been, right? And if c, the hypotenuse, is bigger, guess what kind of angle you have? A bigger than 90 angle, which is called obtuse. So if c squared is bigger, then you have an obtuse triangle. And the obtuse angle will be the one across from c. And now, I know this is going to shock you, but I want you to try really hard. What do you think happens if c squared is less than a squared plus b squared? It's an acute triangle. Well, it's just crazy. And so you go, okay, let's test this out then. So first we're going to say, I'm going to just give you 3 numbers, and I'm not going to even draw the picture for you. I want you to think back to last unit. First of all, do these numbers even make a triangle?
Yes.
How do you tell if they make just a triangle?
You have to add them and see.
You have to add, remember, 2 sides have to be bigger than the third? Now this isn't the Pythagorean theorem, this is just testing if you're a triangle at all. So you check, so somebody check for me. What's 4.3 plus 5.2? Is that bigger than 6.1?
Yes.
Okay. Is 5.2 plus 6.1 bigger than 4.3?
Yes.
Okay, y'all are checking for me. Is 6.1 plus 4.3 bigger than 5.2?
Yes.
Cool. So yes, we have a triangle. You want to check that first in case I'm trying to bamboozle you. And you know I will do it because I am out to get you and torture you. Okay? So now we need to classify it. So now that we know it is a triangle, how do we test what kind it is? You're going to use the formula, and I'm going to put this, which one gets to be C? The 6.1, the biggest is always C. So I'm going to put that in there. So I'm going to say, okay, is 6.1 squared bigger, smaller, or equal to 4.3 squared plus 5.2 squared?
What's the circle stand?
That's me trying to figure out, I don't know what goes there. Is it going to be bigger than, smaller than, or equal? You could put like just an empty space there if you want. And so you're going to put this in your calculator. And what does the 6.1 squared come out to be? 37.21. And then you've got your blank space. And you have 18.49 and 27.04 for these two guys squared. So put those in your calculator. What does it come out to be? 18.49 plus 27.04.
That's greater.
No, what number is it? I don't know what number, you guys, I don't have a calculator. What number is 18.49 plus 27.04? 25 point what? 45.53. So this is my C squared. Is it bigger than or smaller than the other two squareds? It is, 37 is smaller than 45? Okay, so if 37 is smaller than 45, C squared is less, so what kind of triangle do I have?
Acute.
Acute. So not only is it a triangle, we now know it's an acute triangle without ever actually seeing a triangle. Now watch what happens. If I sketch it now, I know it's an acute triangle, and I'm going to have what? A, B, and C. And you said C had to be acute, right? Well, what do triangles add up to? 180. So if this guy is less than 90, in order to add up to 180, how much do these two guys together have to be? They would have to be bigger than 90 in order to add up with something smaller than 90 to be 180. So these would have to be bigger than 90 together. If this is smaller than 90, this other two together have to be bigger. So like if this was 75 degrees, how much would these two have to add up to? They'd have to add up to 105 to make the whole triangle be 180. Okay? I'm just telling you that because there's problems like that in your homework where you have to think that way. If I know this one angle is acute, how big do the others have to be? And now you don't know how big they are individually, but you know that together they better be bigger than 90. Okay? So try this guy.
How do we know that was 75?
How did I know what was 75? I just made up a number.
Oh, okay.
This was just an example. I said if it was 75, then that would have to be. Okay? We did not know that one. Thank you for clarifying. Okay? So now, on this one, go ahead and figure, I'm going to tell you this one is for sure a triangle. Okay? So you don't have to check that. I want you to figure out what kind it is using that formula. So go ahead. Right. Calculate. Oh, you're all so trusting.
We can all use it. Reese, go get It sounds like you're actually
Yes, you can see a lot of
That's wrong. We don't know if it's equal yet.
I wonder how many get bamboozled by this one.
Oh, no, she just said it's a triangle.
It is a triangle for sure.
But we don't know if it's the right acute or obtuse.
You're trying to figure out if it's right, acute, or obtuse.
It's not equal. It's not equal. It's not equal.
So is it acute or obtuse then?
It is, my verdict is up
It would
to.
be 4 plus 36. 40.
Now, you guys, what do you have to do before you start? Yes?
I know which side is the hypotenuse.
Which side is C? Shh. It might not be a hypotenuse because it might not be a right triangle. But we always need C to be the longest one. So which one gets to be C?
3 times square root of 3.
How many of you said 6 was C? Because it's not. Because somebody put in your calculator, how big is 3 root 5?
6.7.
Can you show how to do it on the calculator again?
Okay, somebody hand me a calculator. Thanks. Okay, so you got your calculator. If you want to put in 3 root 5 and see how much it is, you type 3, and then the square root is up above the x squared button. So you're going to have to put second, and then the x squared, and it should pull a square root up. And then we've got a 5 underneath it. And I want to know how much that is? Hit enter.
Yeah, but how do you square it?
Okay, well this is 6, hold on, so first I've got 6.7, so I know this is C. And so I have to set up 2 squared plus 6 squared I don't know if it's bigger than, less than, or equal to whatever 3 root 5 squared is. Okay? So now that you've got that, now you're ready to put it in. This side you don't need a calculator for. What's 2 squared?
4,
What's 6 squared?
36,
Which together makes
40.
40. So we've got that. To do 3 root 5 squared, you're going to put a parentheses. You're going to do 3 root, see, I already screwed up. Clear, second quit. So 3 second square root 5. Now, to get the parentheses not in the radical, I have to get out from under the radical. So see how it's got a little arrow blinking there? Guess what I'm going to do? Press the arrow to get out. Now I can close the parentheses and hit squared. Or, could you just do this the way we taught you to do it in day 1? Yeah, you could do 3 root 5 times 3 root 5. What's 3 times 3? 9. What's root 5 times root 5? Root 25. What's the square root of 25? Times 9 is 45. Let's see what the calculator says. Oh, look, it says it's 45 as well. Okay? So you get the same thing. And so now you ask yourself, is 40 bigger than, less than, or equal to 45?
Less than.
So is this acute, obtuse, or right?
Obtuse.
But wait a minute, this was less than.
But that's A and B.
But I wrote it backwards. We want to see if the c squared is bigger than the sum of the other two. If c squared is the bigger thing, it is an obtuse triangle. And guess which angle is the obtuse one? The one across from the letter C. Okay? Alrighty. So there are more examples in here. Given triangle lengths 3, 4, 6.
There, that's a triangle.
Is that a triangle?
Yes.
Yes. 3 plus 6 is bigger than 4. 3 plus 4 is bigger than 6. 4 plus 6 is bigger than 3. Okay? What kind?
I'm figuring it out right now.
I can do it without even adding.
Oh.
Is it right because...
No, it's not right because 3 and 4 have to give you a 5 to be a right triangle. And so since C here is bigger than C here,
It's obtuse.
I'm going to go with it probably being obtuse. Okay, let's check. 3 squared plus 4 squared and then 6 squared. So it gives me 25, because I know that triple. This comes out to be 36. 36 is bigger than 25, so I know it's obtuse. Okay? Alrighty, you have the remaining 20-ish and change minutes in class, plus advisory, to work on your assignment.
I don't know.